Hello everybody, this is Mr. Chen, and I'm not here, but I'm there with you in spirits, and we have to move on to our next lesson. So let's go ahead and read what we have in front of us here. Let's see, so I'm starting with on top. What about us? So far, all the curves we have analyzed have been functions. We could identify critical values using the first derivative and evaluate the function to get the corresponding output. What about other relations? We have problems that want to be solved too. Okay, so first thing we can see this relation here, this graph, it doesn't pass the vertical line test, and we can see that since there's the vertical line touches the graph at 2 points at the same time for the same x value. So right now you should probably pause the video and go ahead and answer number 1 through 6. And when you are ready, you can go ahead and restart the video, and then we can go over the answers and start from there. All right, so you have attempted number 1 through 6. Let's go over the answers. So first thing first, number 1, where does this graph have vertical tangents? Where does this graph have horizontal tangents? So you should say something like vertical tangents at x equals 2 and negative 2. Because we can see that right here. These are my vertical tangents. Right here. And right there. And you should have said something about no horizontal tangents. Because there's nowhere where we can draw a tangent line with a slope of 0. And remember, when do you have vertical tangents? You have vertical tangents when y prime is undefined, and you have horizontal tangents when y prime is equal to 0. Just keep that in mind, okay? Next thing, let's look at in which quadrant is this curve increasing? In which quadrant is curve decreasing? So I'm looking at the graph here. I can see from left to right, I'm doing increasing first. Right here it's increasing, so that's quadrant 1, 2, and 3. 3. And the other one is at quadrant 1. So you should say something about increasing in Q1 and Q3. And the other one, we can see that the quadrant 2 is decreasing from left to right, and quadrant 4 decreasing from left to right. So we can say decreasing in quadrant 2 and quadrant 4. Number 3, we gotta find dy dx using implicit differentiation. For those who don't remember, implicit means you're differentiating when y is not isolated, and we have to do y prime every time we derive anything with y in it. Okay, so first the function itself is up here. X squared over 4 minus y squared equals 1. So I'm gonna write that down first just for organization's sake. So x squared over 4 minus y squared equals 1. Let's see, zoom out. Let's zoom a little bit. I'm gonna rewrite this to help me. I'm gonna do 1/4 x squared minus y squared equals 1. So I just know to use power rule with the fraction here. So that's derive. Let's see, that should be, bring the 2 down, becomes 2 over 4x minus dy dx, because I have a y right there. Dy dx, power rule, 2y equals 0. I can simplify here, so I have 1/2 minus dy dx times 2y equals 0. Some of you might have forgotten to isolate dy dx. I need to isolate it because I'm looking for it. So first thing first, I'm going to minus 1/2 x to both sides. So now my equation looks like this. Dy dx equals negative 1/2 x. Ooh, I forgot the 2y. The 2y should be there in the front too, right there. And next thing I'm going to divide. I'm going to divide 2y so I can get 2 dy dx by itself. So right there, that's my, and now my dy dx isolated. If I simplify a little more, multiply by the reciprocal, etc., etc. Oh, ooh, I forgot something. Right here. Do you guys see the negative sign in front right there? I forgot to put that there. Let me add that in. So it should be negative right there, divided by negative, divided by negative. Okay. If you were to simplify all the way, you should have gotten x over 4y equals dy dx. This is the complete derivative of using implicit differentiation. All right, folks, let's look at number 4. How does the equation for dy dx support your answers to question 1 and question 2? So I'm going to write dy dx first. So we knew that dy dx equals x over 4y. I'm going to sketch a graph really quick, just for reference. So we have something like 2 right there, negative 2. You don't have to do this part. I'm just doing it so we have a visual. We can refer to it as we talk. So first, number 1 was about vertical and horizontal tangents. So first thing first, well, let's talk about the 2 vertical tangents that we do have. And we talked about the fact that we have vertical tangents when y prime is undefined. When y prime is undefined. Everyone, let me ask you this question really quick. How do we make this expression, dy dx, which is my y prime? By the way, I'm writing it in just to remind you. This is the same thing. How do we make this expression undefined? I hope you said something like, we need the y, the denominator in this case, we need the denominator to be 0. So when the denominator is 0, then that means the y value is 0. Take a look. Look, and we said the vertical tangent was happening at negative 2 and 2 for x. But look at the y value at these locations. So you can see at this point, right there, my coordinate was 2, 0, and then negative 2, 0. And that connects back to this idea. We need the derivative to be undefined. In this case, the denominator to be undefined. And you can see that the y value is 0. That's why you make a denominator equal to 0. So you can write, the statement you should be writing down is y prime, or dy dx, is undefined when y equals 0, and that's also when x equals plus or minus 2. Let's look at number 2 about increasing and decreasing, right? When is y decreasing? When's y prime increasing, meaning y prime is positive? When is y prime decreasing, meaning y prime is negative? So let's look at what's happening. Y prime is positive. Well, where's the slope positive, folks? The slope is positive in quadrant 3 and quadrant 1. Quadrant 3 and quadrant 1. And what's special about those quadrants, about the x and y value? You should have said something like both x and y is negative here. So if I plug in negative and negative, when I divide them, what do I get for my derivative? Oh, I get a positive. How about quadrant 1? X and y are both positive. So I plug in a positive by a positive, I'm going to get a positive, right? So in this case, y prime is positive when x and y have the same sign. And this problem is in Q1 and Q3. And of course, I'm sure you can utilize a pattern now, looking at when y prime is negative. When is our slope negative? And you can see it's in quadrant 2 and quadrant 4. In quadrant 2, what's positive, what's negative in terms of x and y? Well, in this quadrant, my x is negative, my y is positive. So I have I have a negative divided by a positive, so my answer is going to be negative, my slope. And in the quadrant 4, this time my x is positive, my y is negative. So when I plug it in, it's positive divided by a negative, and then my whole derivative becomes negative. So y prime is negative in this problem when x and y have different signs. Q2 and Q4. And notice one thing we talked about as well we didn't talk about when dy dx equals 0, when the slope equals 0. I want to take a second to do that. You don't have to write this down, but I just want to show you something. So do you guys see? Here we go. Let me write on the edge here. So the original equation was x squared over 4 minus y squared equal 0. Sorry, equal 1. And if I go back and look at my derivative equation right here, maybe if I asked you, how do we make this derivative equal to 0? You might say something like, oh, we can just make the numerator equal 0. What if x equals 0? However, that's a problem because it actually doesn't satisfy our original equation up here. Let's see what happens. So if I plug in 0 for x, right? So 0 squared over 4 minus y squared equal 1. So then the 0 squared over 4 becomes 0. So we just have negative y squared equal 1. Let's say we give it a negative sign. We'll divide both sides by negative 1. So we get y squared equals negative 1. And then you square root, but you get y equals plus or minus square root of negative 1. And this is an imaginary number. So do you guys see how where we think we can possibly have a derivative of 0 by plugging 0 for x, it doesn't fit our original equation. So therefore, it does not exist. Therefore, we don't have a place where y prime equals 0. And at the same time, go back and look at our graph, right? Do you guys see how 0 is not a domain? Our domain is from negative infinity to negative 2. And it skips to 2 to infinity. 0 is not part of the domain of this relation. So as a result, we don't have anywhere where our derivative is going to equal 0 in the end, right? Just want to kind of show you guys that, because sometimes when we do these, when we look at these relations, we have to go back and check to make sure whatever answers we choose actually can be solved and have solutions in the original equation. Okay, let's look at number 5. So when is the curve concave down, and when's the curve concave up? Well, concave down, you should have said something about quadrant 2. I can see it's opening down, and quadrant 1. Oops, sorry. Well, what is happening? What else is happening in these particular areas? What do you notice about the y value? In these places, do you guys see how the y value is both positive? So that's just something I want to note for now, and we'll come back and visit. In these places, y is greater than 0. Okay, well, we're in a positive section. And for concaving down, concaving up, you should have picked something in terms of quadrant 3, opening down upwards, and quadrant 4, opening upwards. So quadrant 3 and quadrant 4. And the y value, I'm sure you notice, is in this bottom section right here, below the x-axis. So this is where we know that the y is less than 0. Let's go ahead and talk about the next section, number 6. All right, so number 6. It can be shown that the second derivative of y is negative 4 over 16y cubed. Explain how this equation supports your noticings about the concavity of the curve. So this, once again, is about plugging in x and y values and finding out what the sign of your second derivative. And that matters because we know that the second derivative tells us the concavity of an equation. Sorry, a relation in this case. So what's happening in quadrant 1 and 2 when y is greater than 0? Well, we can see that by plugging in a positive number here. It's going to be positive in the denominator because everything is positive. And negative divided by a positive will be a negative. That's why when y prime is greater in that's why when y is greater than 0, we end up getting a concavity of negative. Sorry, a concaving down because my second derivative is negative. So let's write that down in terms of d squared y dx squared is less than 0 when y is positive. And that's my Q1 and Q2. And on the other hand, in the other case, for quadrant 3 and 4, when y is less than 0, when plugging a negative number there, say let's just choose negative 1. Negative 1 cubed is negative 3 times 16, a negative number. Negative 4 divided by a negative number is positive. So therefore, in this case, our second derivative for our relation is greater than 0 when y is negative in quadrant 3 and 4, ultimately making our whole second derivative positive, and therefore we have a concavity of concaving up. All right, so some important ideas. Implicit differentiation. To find first, second derivative of relations. The next thing, though, here's a key idea that's a little different. The critical points, like our vertical tangent, remember it was 0, 2, 0, and negative 2, 0? The critical points now are x and y values. Not just x values anymore, it's x and y values. And when do they happen? These happen when our dy dx equals 0 or is undefined. And we have to make sure they satisfy the original equation. Like that 0 we plugged in to the original, it didn't work. This is a key thing we have to check, okay? The next thing. A curve is increasing when dy dx greater than 0 and decreasing when dy dx is less than 0. And we have to make sure to specify x and y values. Make sure we specify both of those. And lastly, a curve is concaving up when the second derivative is greater than 0 and concaving down when the second derivative is less than 0. And we also need to specify x and y value. Go ahead, feel free to pause the video to finish writing and then turn to the next page and we'll do some practice. So at this point, you should go ahead and attempt these problems one by one. When you finish 1A, 1B, 1C, start the video again. Try 2 and then watch a video. Try 3 and then watch the video and listen for my explanation. All right, so looking at number 1 right there, I'm going to read the problem and then go over each part. Let's see here. Consider the curve in the xy plane given by blah. It is known that the first derivative equals and the second derivative equals. Okay. And for part A, find the critical points of this curve. Justify your answer. So first thing first, I'm looking at the critical. I know I'm looking for critical points. And what am I looking for? Oh, I'm looking for when a derivative, first derivative is equal to 0 or is it undefined. So I'm looking at this particular, I'm looking at the particular derivative, 5x over y. Well, how can I make it 0? Oh, the whole thing is 0 when x equals 0, right there. The second one is how can I make this function undefined? It's undefined when y equals 0. So those are my two potential places that I could have critical points. So, excuse me. So I'm going to go ahead and now plug these numbers back into where? We're going to plug it back into original to see if we can find, to make sure they work, and also to find the x and y value, right? Keep in mind, we need x and y values. So I'm going to go ahead and plug in the 0 first to the equation. So I have 0 squared minus y squared over 5 equals 1. I'm going to simplify. That becomes 0. This is a negative 5 right here. I'm going to multiply by negative 5 to both sides. So I get y squared equals negative 5. I know that I can't square a number and get a negative answer. Any number squared is positive. So I know that right here, 0 is not part of the domain. So this right here does not give us a horizontal tangent because there's nowhere where the slope is 0. Okay, so not part of the original. So 0 is not a critical point. Or x equals 0. It's not a critical point. Now I'm going to check using the y one. So let's plug in the y. So I have x squared minus y squared. Ooh, not y squared. I'm replacing y. Let me erase that. Replacing 0 squared over 5 equals 1. Go ahead and solve that. This becomes 0, so I have y squared equals 1. I can square root both sides. So x actually equals positive 1 and negative 1, which makes sense because I square root both sides. And now, remember, what did the making y give us for the first derivative? It gave us undefined, meaning vertical tangents. Okay? So then we have these x equals 1 comma 0 and negative 1 comma 0. These two are critical points because dy dx is undefined, and there's also it works with the original equation. So let's write that out for our final answer. We can write that dy dx is undefined when y equals 0 and x equals positive negative 1. Or you can write 1 comma 0 and negative 1 comma 0. This works as well. Okay? Part B, is the curve increasing or decreasing in quadrant 4? Justify your answer. Well, if I'm looking for increasing or decreasing of a graph, I know I'm looking at the first derivative once again. So once again, I know I'm looking at the first derivative of 5x over y. I got to think about quadrant 4 in terms of my x and y values. So in quadrant 4, right here, my x value is going to be positive. My y value is going to be negative. If I plug that in, I will have a positive number. 5 times a positive is a positive over a negative number, and I'll get a negative number. So at the end, I know my graph's going to be decreasing because my dy dx is going to be less than 0 in quadrant 4. It's going to be negative. So curve is decreasing. And this will be my justification right there. Number three, is the curve concave up or concave down in quadrant 4? Justify your answer. This time, we're looking for concavity. So that means I'm looking at the second derivative. I'm going to use yellow here. I'm going to refer back to here so you can have color coding. So I'm looking at the second derivative. So I'm going to write it down, negative 25 over y to the third. So I'm looking at quadrant 4 once again. Simple. We know that the sign is going to be positive and then negative. But in this case, I don't have to plug in anything for x. I'm just plugging in for y. So I have negative 25 over y cubed. So I know my y is going to be negative there. So let's say negative 2. Negative 2 cubed is going to be negative 8. So I have a negative over negative equals positive. So the conclusion is that my second derivative is going to be positive in the fourth quadrant. Therefore, my graph is going to be concaving up. Right? So now I can go ahead and write my statement here. Let's see. So dy dx is greater than 0 in quadrant 4. So curve is concaving up. All right. Number 2. Make sure you have attempted it first before you check my answer. So in this question, this is just a practice for implicit differentiation. We have to go ahead and find the derivative. So let's see here. So first thing first, what would I do? So I have to use product rule right here. So f prime of g plus g prime of f. That whole thing will be minusing. Oh, I have a nice little quotient rule there. So I have low d high minus high d low all over low squared, low. And on the right side, I have negative 2, so the root adjective becomes 0. Right? I'm just setting up the boxes, so it just to review for some people. F prime x squared is 2x. Y is my g, just leave it alone. G prime right here is just my y, so the derivative of y is 1, but since I'm dividing y, I gotta write dy dx. My f is x squared, leave it the same. Let's do the quotient rule. Low is y, d high is just 1, minus high, that would be x. D low, y is just dy dx, all over low squared, so y squared. Okay, let's go ahead and simplify and write it a little nicer, a little more compact. So 2xy plus dy dx x squared minus this thing in the middle. So that would be y times 1 is y, minus dy dx times x, all over y squared equals 0. We want to go ahead and we want to move every term that has a y squared, that has dy dx to one side, and everything else to the other side. Okay, so I'm looking at this problem right here. I'm like, oh man, I see the y squared in the denominator, so I'm going to multiply the whole equation by y squared to get rid of it. It's another way of finding common denominator. So I'm going to multiply the whole equation by y squared. So now I have to distribute 2xy cubed plus dy dx x squared y squared. The y squared will cancel out here for us for this term. So I'm also going to distribute a negative sign. It becomes negative y plus dy dx all over, dy dx times x equals 0. Next, I'm going to do some subtracting and adding here. I'm going to move this term, because it doesn't have dy dx. I'll move this term, because it doesn't have dy dx, to the other side of the equation. So I'm going to subtract them. So my new equation now is dy dx x squared y squared plus dy dx x equals, and then we'll move these two terms over. So it becomes negative 2x squared, negative 2xy cubed plus y. I'm almost there. Now that we have isolated the dy dx term, I can do some factoring. I'm going to write it right below here. So dy dx factored out becomes x squared y squared plus x, and then equal that right side that we have not touched yet. Like that. And of course, last step, I just divide the whole thing by x squared y squared plus x to both sides. So dy dx is equal to this ugly thing on the right side. Here we go. Looking at number 3 now. Looking at number 3. Multiple choice. Which of the following describes the y-coordinates of the points on the curve EX equals sine y, where the curve has a vertical tangent line? What are we looking for here? We're looking for where we have a vertical tangent line. Well, what should that trigger in your memory? Vertical tangent line means when my first derivative, when my y prime dy dx is undefined. Good undefined right there, I know. So now, first, that tells us we have to find the y prime first, or dy dx. We have to do the first derivative. So you should find the derivative of that. So the derivative of that equation becomes ex equals, since I'm finding the derivative of y, I got to do dy dx, derivative of sine, cosine y. Of course, we're not done. Dy dx is my y prime. I got to isolate y prime by dividing cosine y to both sides. So I get dy dx is equal to e to the x cosine y. Well, the next question is, well, when will we have undefined? Well, we have undefined dy dx when our derivative, when our denominator is equal to 0. So the next question is, okay, cosine y is equal to 0, because I meant denominator equal to 0. Well, when is cosine of what? Of what angle is equal to 0? You should be imagining a unit circle in your head, and you go, oh, I know where. Cosine is my x value. So this happens at 0 right here. Cosine 0. Oh, no, I'm wrong. Apologize. Cosine is my x value, so my cosine is 0 at pi over 2. So y is going to be equal to my pi over 2. It's going to be at 3 pi over 2, 5 pi over 2, etc., etc. And if I were to go in the negative direction, that would be negative pi over 2, negative 3 pi over 2, etc., etc. So you guys get the idea, right? So these are all the places where my cosine will be equal to 0. Let's look at our answer choices to see which one will be correct about that. Let's see. So look at the first one. N plus 2 plus n pi for all non-negative integers of n. So this one's claiming that n has to be positive, so we can only have positive angles. No, we can definitely have negative angles, so A is not right. Number 2, 2n pi. That means that if we plug in 1, right, so it becomes 2 times 1, and times pi is 2 pi. So it's saying we have to go in a 2 pi circle. So we have to go 2 pi every time, so 0, 1, 2 pi, 2 pi, 2 pi. But then now that answer choice B is neglecting the bottom portion, the 3 pi over 2 portion. So therefore, we know that B is not the correct choice. Let's check C. So C would be about pi over 2 plus n over pi. So 1 pi, well, yeah, that makes sense, because 1 pi this way is that's the distance right there. That distance here is pi, right? From pi over 2 to 3 pi over 2. Once again, right, a lot of unit circle work. A lot of you are not memorizing unit circle. You need to memorize it, because it comes up over and over again on the AP test. Memorize it, please. Memorize your unit circle. So C looks like a potential answer here. Let's look at the last one again. Let's look at the last one. The last one says that the value pi over 2 plus 2n pi for all integers. I know 2n pi is not correct already, because then if I plug in 1, that means I have to go a full circle, 2n pi, and that's neglecting, once again, right there. Okay, so the answer is going to be C. Go ahead and turn the page. Sorry, at this point, you should be getting a different packet from Mr. Moreno that says, I believe, number 21. All right, everybody. This right here in front of you, this is our assignment number 21. But we have plenty of time in class. So if the assignment is all, but we're going to do quite a few in class together, okay? So you're going to try a couple problems here. So let's see. First, I'm going to put a star next to problem I want to go over with you in class, so we can discuss them. You can work in individual or groups. Either one is fine. By the end of the day, make sure you understand what's happening, okay? So I want you guys to definitely do this one right here. I want to do that one, okay? Let's start with those two. Go ahead, pause the video, try them yourself, and then restart it when you're ready. All right, let's go to the first one. So first one, it says find the second derivative in terms of x and y. I'm looking at the problem here. We're given the derivative already, so I gotta find the second derivative. So I gotta find the derivative of this to get that. So let's go ahead and start that work. So I derive both sides, so then my d, I get d second derivative on the left side from here equals, find derivative of this whole thing, derivative of 2x, x squared is just 2x, and derivative of y, I know it's going to be minus dy dx, and derivative of 1/2 y is just 1/2. Some of you might be like, okay, am I done? No, remember the tricky part about second derivative is, you see dy dx right there? I have to replace dy dx. I have to substitute dy dx right here, back there, because I already have it, okay? So you should be having 2x minus parentheses x squared minus 1/2 y times 1/2. Once again, when you find second derivative, you have to plug the first derivative back in because we already know the known value. We already know where it is. Okay, let's do some simplify. Let's simplify, and we can be. Actually, we don't really have to simplify, honestly, but simplify just for practice sake. Some of you need that practice. So equals 2x. That's gonna stay the same. I'm gonna distribute the 1/2 and the negative 1/2. So it becomes negative 1/2 x squared. And then negative 1/2 times negative 1/2 y becomes positive 1/2 times 1/2 is 1/4 y. Oops, that's not good. What's happening? Ay. Plus 1/4 y. Okay, so then that would be your complete answer. Second derivative is equal to that. Next question. This one is a good summary for us because it has a little bit of everything, okay? So, a curve in the xy plane is defined by the equation, which of the following statement is true? At a point where x equals -2, the lines tangent to the curve are horizontal. So right here, you should be thinking, okay, I need to find derivative and then set it equal to 0 because it's a horizontal tangent line with a slope of 0. Number 2, at a point where y equals -8, the lines are tangent to the curve are vertical. Oh, vertical is when my first derivative is undefined. Most times my denominator equaling to 0. Keep that in mind. Third, the line tangent to the curve at the point -1, 1 has a slope of 1/2. So if a line tangent to a curve at that point, so if I plug in -1, 1 into my derivative equation, I should get a slope of 1/2, okay? So this problem is all about first derivative. So of course our task, I hope you already done that, our task to find the derivative. So let's do that first. So let's see, x cubed becomes 3x squared plus y squared, that becomes dy dx 2y. Negative 12x becomes just -12. 16y becomes positive dy dx 16. 28 becomes 0. Okay, so that's our first step. And now you should recognize the dy dx on the left, these two terms, and the two terms that do not have it, 3x squared minus 12. We're going to move that to the right side. So my next step of the equation look like this, only dy dx on the left, dy dx 2y plus dy dx 16 equal to -3x squared plus 12. Next, we factor the dy dx. 2y plus 16, 3x squared plus 12. I'm going to divide both sides by 2y plus 16 in order to isolate my dy dx. I hope you're writing a little smaller than I am. Sorry, it's a little harder to write small on this format as iPad. So dy dx equals to -3x plus 12 all over 2y plus 16. So this is going to help us do everything else, okay? So let's check the first one to see which ones are true. That's what our problem says, which ones are true. So first one, where x equals -2, the lines tangent to the curve are horizontal. Horizontal means that the whole thing is equal to 0. So if you look at our equation here for our dy dx, that means the numerator has equal to 0. Let's check. So if I set -3x plus 12 equal to 0, I'm going to go ahead and solve that. Oh, 3x squared, I forgot the square. sorry, 3x squared, right there, 3x squared. So minus 12 to both sides, negative 3x equals negative 12. Divided by 3 to both sides, negative 3 to both sides. X squared equals 4. So square root x equals plus or minus 2. Yep, makes sense. Negative 2 is right there, so we know that A is true. I'm gonna put a little t next to it in green. That is true. Okay. Second thing, let's check for part number 2. At the points where y equals negative 8, the lines tangent to curve are vertical. Well, vertical as being undefined slope. That means my denominator has to equal to 0. And let's check that. So 2y plus 16 equal to 0. Minus 16 to both sides, 2y equals negative 16. Divide y equals negative 8. Great. So 2 is also true in this case, because that makes our derivative, the denominator of our derivative, equal to 0. Check the third point. The line tangent to the curve at negative 1, 1 has slope of 1/2. This whole equation is slope. If I plug in negative 1 for x and 1 for y, do I get 1/2? That's essentially what's asking. I'm going to do the work on the side. So I have a little more room here. I'm just going to plug it in. Negative 3, I'm going to plug in the negative 1 for x squared plus 12. All over 2, I'm going to plug in the 1 for y plus 16. Just doing some work here. Negative 1 squared is 1 times negative 3 is negative 3 plus 12. All over 2 plus 1 is 2 over plus 16 is 18. So this becomes positive 9 over 18, which equals to 1/2. And yes, that's what we're looking for. So part 3 is also true. So after doing all that work and checking, the answer is D, because all 3 are true. Go ahead and now attempt this next problem and restart the video when you're ready. So, what are we looking for? We are looking for when the curve has a horizontal tangent. So what does that mean? Oh, that means I gotta find first derivative. That means I gotta set it equal to 0, and I gotta make the numerator equal to 0, because then the top has to equal 0 in a fraction for the whole thing to become 0. Okay, so that means I can find derivative first. Derivative first becomes 2x equals derivative of x minus y. So let's see, derivative of x, I gotta do chain rule, right? Because I do derivative of x minus y first. Derivative of x is just 1 minus y, but derivative of y is just 1, but then since it's y, I got to do dy dx. Times derivative of the whole thing. We know that e just stays the same, so it looks like this. So I'm going to choose now to distribute the e to the x minus y to help us solve. So we have 2x equals to e to the x minus y right there, minus dy dx times e x minus y. Next, let's subtract e to the x minus y to both sides. So I have 2x minus e to the x minus y equal to negative dy dx times e to the x minus y. Now let's go ahead and divide. To get dy dx by itself, I'm going to divide both sides by negative e to the x minus y. Therefore, my dy dx is also isolated. So now, to go back to the original idea, right? Don't get caught up in all this solving and work. But we're looking for when does a curve have a horizontal tangent. A horizontal tangent happens when our derivative is equal to 0. This is our derivative. And when derivative equals 0? When the numerator equals to 0. So let's make that happen. So we can just simply take our numerator, 2x minus e to the x minus y equal to 0. And we solve this. Some of you might be like, oh my god, I don't know how to solve this. Well, let's see. Let's review. I'm gonna add e to the x minus y to both sides. So 2x equals to e to the x minus y. Now I have this. And at this point, that's just something really helpful. Do you guys see how e to the x minus y is equal to x squared? Once again, e to the x minus y, right there, it's equal to x squared. So I'm simply going to substitute. So 2x equals e to the x minus y becomes x squared. And now I'm going to solve. In order to solve, I'm going to minus x squared. I'm going to minus 2x to both sides. So 0 equals x squared minus 2x. From there, I'm going to factor. So 0, x times x minus 2. So I have two answers. I can either have x equals 0 or x equals 2. But I go back and look at the question. It says x is greater than 0. Greater than 0. So that means that x cannot be 0. It's greater than 0. So my only answer is x equals 2. So my answer is C. That's the number that's going to make our derivative equal to 0. Okay, our denominator equal to 0. The next question I would like you to attempt is this one right here. Okay, go ahead and try it yourself, and then you can watch the video when you are ready. Okay, so this problem, let's read it first. Let C be the curve defined by x squared plus y squared equals 36. Consider all points x, y on the curve C where y is greater than 0. So I'm already looking at, okay, it wants me to focus on when y is positive, y is greater than 0. Something to keep in mind. Which of the following statements provide a justification about the concavity, for the concavity of the curve? Concavity. Ooh, what tells me about concavity? Up or down? Second derivative. So I already know right now I gotta find derivative twice. Some of you might be like, ugh, yes, we gotta do it twice. Let's do it. So first derivative, relatively easy. X squared becomes 2x. Y squared becomes dy dx times 2y equals 36. Let's go ahead and, oh, sorry, 0. That should be 0. Let me erase that. Let's go ahead and isolate. So dy dx equals 2 times 2y equals negative 2x. I minus to both sides. Divide by 2y to both sides. Dy dx equals 2. Simplify, please. 2 divided by 2 is 1. Negative x over y. I asked for you to simplify because it's going to make your second derivative a lot easier. We're on the first derivative. We've got to do it again. To find the second derivative, we've got to do some quotient rule here. So d squared y over dx squared equals to low y dx, negative 1, minus high, negative x, derivative low, dy dx, all over low squared, y squared. At this point, remember, we cannot leave dy dx by itself. We have to replace, because we know what dy dx is. We have to substitute dy dx right here, right back there. Okay? So let's write a simplified form. D squared y dx squared equals to negative y. Let's see, plus x times negative x over y all over y squared. Let's continue. So I'm going to simplify some more. So I have, let's see, what do we have here? We have negative y minus x squared over y all over y squared. So that's what we have there. And I'm looking at, this is the correct second derivative. But I'm looking at all the answer choices. I'm like, wait, how come they all either, it's much simpler than mine. So they must have done something else to make their derivative simpler. In this case, they actually did some fancy substitution to get rid of to simplify one of the variables even more. To be more specific, this is what we have to do. So I'm looking at this numerator right here. I'm like, oh, it's messy. I'm going to do common denominators. The common denominator is y. So it becomes negative y squared minus x squared all over y squared. And if we were to multiply the reciprocal to make it even nicer fraction, now we have negative y squared minus x squared all over y cubed. If you don't know why, we multiply by the reciprocal of y squared was 1 over y squared. Y times y squared is y cubed. Okay, that's where we got that from. At this point, I'm looking at my answer choices. I'm like, oh man, this still doesn't make sense because the second derivative, I still don't see anything that resembles my solution. Your clue here is, wait, you have a 36 there. You have a 2y there. So what they did was actually they went back to the original equation, folks. and they isolated for y. Let's see how we did. They isolated for y squared. So do you guys see how if I subtract both sides, the x squared to both sides, y squared equals 36 minus x squared right there, like that? So what they did was they substitute this y squared right there for y. So we have negative, parentheses, we plug in 36 minus x squared all over y to the third. Distribute, negative 36 plus x squared minus x squared over y to the third. That's quite nice. Extra cancel out for us. And now this is a alternative form of our second derivative, right? So now that helps us limit the choice down. I'm going to narrow that down a little bit here. Hold up, sorry. That helps us narrow down our choice to either C or D. C or D, okay? Because that's where our second derivative is. Now, let's plug in numbers. We know that y is greater than 0. So if I plug in a positive number here, positive to the third power is what? Positive. I have negative divided by positive, so it's going to be a negative number. So then my second derivative is going to be less than 0, because if I plug in a positive y, my whole thing will be negative. That means my graph's going to concave down. That's why the correct answer is C. Not an easy problem, it's really that last tricky step to substituting. That's what I want to go over with you, kind of expose you guys to this problem type. Go ahead and continue working on the rest of your problems. I'll post answer on Google Classroom. Your homework this weekend is number 20, the optimization problems you started in class at the beginning of class. So that's what's due. For this stuff, we'll continue practicing on Monday before we review, and then we have a unit test next week on Thursday or Friday, okay? Thank you guys, and have a good day. Not 1, 2.